ninjani ngiyaphila nami ngiyaphila if ningibulisile. So in the last video we were finishing off on my arithmetic sequence. So in this video we start a geometric sequence. I don't think this one will be that long because since we got to understand arithmetic, this one will be much easier because there's a few difference, but in attempting our questions it's more like the same procedure, right? So unlike in the arithmetic sequence where we had to find the common difference, here we are talking about what? The common ratio. So now let's focus on the sequence I've written here on the board, 7, 14, 28. You will notice that if we divide any terms in the sequence by its previous term, we always get a value of 2, right? So if I take T2 from this sequence, we see that 7 is T1, 14 is T2, and 28 is T3, right? So if I divide T2 by T1, this is going to be 14 over 7, I get 2. Divide T3 with T1, 28 over 14, again I get what? 2. So which means we are saying that Tn over Tn minus 1 gives us what? 2. So in every successive term, if the sequence would continue, we are expecting to get what? A common ratio of 2 when we divide what? The previous term, the next term with its previous term. So remember on the arithmetic sequence we said T2 minus T1. That gave us what? The common difference. In this case we are saying T2, let me not use T1 and T2. We said Tn minus 1. We got what? The common difference. So here we are saying what? Tn over Tn minus 1 to get what? The common ratio. Sharp. Okay, so we go on to find what? The general term of the geometric sequence. So I've written a statement that I'll be using to find the general term. So we say that if A is the first term and R is the common ratio, we multiply by R each time to get what? The next consecutive term. So when we're doing the arithmetic sequences, we said to find the next term, we were supposed to add the common difference. And then here at the beginning of the video, I said to find the next term with geometric sequence, what do you need to do? You need to multiply the previous term by what? By your common ratio. So from the statement, we are already given what? The first term. So term number one is equal to what? A. And we have our common ratio as what? As R. So we have to multiply this R to the first term to get what? The next term. So to get term 2, T2 should be equals to T1 multiplied by R. We already have the value of T1. So T2 should be equals to AR. We get T3. T3 should be equals to T2 multiplied by R. We have already calculated T2. T2 is equals to what? AR multiplied by the common ratio. Therefore, T3 should be equals to AR squared. R multiplied by R, you remember, 2 technique squared. Anyway, grade 12, you should know. We find another term, T4. T4 should be equals to T3 multiplied by the common ratio, R. T3 is what? AR squared multiplied by R. Therefore, T4 is equals to AR cubed. Let's find the last term at least. So T5 is equals to T4 multiplied by R. T4 is what? AR3 or cubed multiplied by R. Therefore, T5 should be equals to AR to the power 4. Right? So if we start from term 5, whenever we're dealing with the term, so for example, term 5, when you look at the power on the ratio, it is less by 1 value. So for term 5, the value of the power in the ratio is 4. So it's more like they said to us, or rather they did this 5 minus 1 in order to get what? The 4. We go with term number 4, same thing. Term 4, we have the power being one less value than the term itself. So it's more like they said 4 minus 1 to get what? 3. Same thing with term number 3, same thing with term number 2, right? So therefore we can conclude that to find the nth or the general term of the geometric sequence is going to be a r n minus 1. So this is what our general term of the geometric sequence. So general spelling general term of the geometric sequence. So when I'm going to so you don't have to so if you see here, most of the video, I mean, just start watching emaphakathini, you won't see because you have to follow what I'm doing. So if you are writing it in an order, you have to put them zlandelana. Yeah, sure. Let's go try. I'm a questions near enough few and then we try. Okay guys, so we have to do questions. So I've prepared 4 questions for geometric sequences, and then I can do each geometric mean. As I said, this shouldn't be too hard because already we have dealt with arithmetic sequences. You will see as we do the questions. Just that here the difference is what? We deal with the common ratio, whilst in arithmetic we dealt with the common difference. Here we multiply to get to the next term. In the arithmetic we added to get to the next term. So oh shit, anyway, so they say here determine the 5th and 8th terms of the geometric sequence 9, 3, 1. So by looking at this sequence we can tell that this is our first term, this is our second term, this is our this is our third term, and we have already derived the general equation for the geometric sequence. So we have what? Tn equals to arn minus 1. Sharp. So since here we are given the first term is 9, we know that our a should be equals to 9. And then what's left for us to do is to find what? The common ratio r. So to make things easier, I'm going to use term number 3 and term number 2. So it's going to be T3 over T2. This should give me 1 over 3. So therefore my common ratio is 1 over 3. So with this information we can go on and find what? The 5th term and the 8th terms of the sequence. So we'll begin by finding what? The 5th term. So the 5th term is what? T5. So for T5 we know that we have the n value of 5. So we can substitute on our general term equation. So we have T5 equals to A is 9 and then multiply by the common ratio 1 over 3. What's the n value? 5. So this is going to be to the power 5 minus 1. So T5 should be equals to 9 multiplied by the common ratio to the power 4. Therefore T5 should be equals to, okay, so T5 should be equals to 1 over 27. So this is what we have. This is our term 5 of the sequence. Then we go on to find what? The 8th term. Same thing. So for term 8 we know that the value of n should be 8, right? We have the first the a value, we have the common ratio. So T8, substituting the equation, is equals to the a value 9 multiplied by the common ratio 1 over 3, the n value, so that's 8 minus 1. So T8 is equals to 9 multiplied by 1 over 3 to the power 7. So therefore the 8th term of the sequence is equals to 7. So that's 1 over 2, 4, 3. And I think I made a mistake here. I punched in 5 in the calculator instead of 4. Yes. So our fifth term of the sequence should be 1 over 9. Sorry guys, yeah. I made a mistake before. We type it as 5 like calculating. So yeah, this is the first questionnaire, geometric sequence. And as you can see, to find the given term of the sequence when you are given the first 3 terms of the sequence is easy as we did before arithmetic, just a different equation. Let's go try a second question. Okay guys, so this is question number 2 of the 4, right? So the question says we should determine the geometric sequence whose second term is -4 and fifth term is 4 over 125, right? So here we are given term number 2 as -4. We are also given term number 5 as 4 over 125, right? And this is a geometric sequence, so we know that we can use Tn equals to a Rn minus 1. Sharp. So here we do not have the a value, we do not have the r value. So in order to solve them together, because there is no first term here, term number 2 can be taken as a, it's not the first term of the sequence. Term number 5 can be taken as a, it's not the first term of the sequence. And we do not have successive terms, so we can't find what the common ratio. What we can do is to create 2 equations from the 2 terms and solve them simultaneously, meaning we'll solve for a and r simultaneously. After we find a and r, we multiply the value of a by the common ratio to find the next term until we find the 3 terms of the sequence that the question is looking for. Okay, so let's start by creating the first equation using the second term of the geometric sequence. So we have for T2, we know that the value of n should be 2. So what we'll do, we'll substitute in the equation. So we have T2 equals to a r2 minus 1. We know that T2 is equals to -4, so we have -4 equals to a r. So I'll divide by r both sides. I want to make a the subject of the formula, so therefore a should be equals to -4 over r. I'll call this my equation 1. We go to the second term, term number 5. For term number 5, we know that n should be equals to 5. So T5 equals to a r5 minus 1. Term number 5 is 4 over 125 equals to a r to the power 4. We call this our equation 2. So we'll substitute equation 1 into equation 2. So this is what we'll have. 4 over 125 should be equals to, where there is a, we substitute this. So it's going to be -4 over r multiplied by r to the power of 4. So we'll have what? 4 over 125 equals to -4 r cubed. So 4 will cancel 4, then we'll have what? Move here to here, we'll have -1 over 125 equals to r cubed. So therefore, to find r, this is what we do. So cube root of 125 negative rather will give me what? 1 over rather -1 over 5. So that means our common ratio is -1 over 5. Now that we have the common ratio, we can substitute it where? We can take the common ratio, substitute it into equation 1 in order for us to find what? The a value. And we know that the a value gives us what? The first term of the geometric sequence. So we have that a should be equals to negative 4 multiplied by negative 1 over 5. Therefore, the a value should be negative 4 multiplied by negative 5. Therefore, a should be equals to 20. So now that we know that we have a as 20, we conclude that the first term that we have should be 20. The second term we are given, so term number 2 should be negative 4. But if you wanted to find it yourself, yeah, you know that to find term 2, it should be term 1 multiplied by your common ratio. Term 1 is 20 multiplied by negative 1 over 5. Remember that your common ratio is negative 1 over 5. Therefore, your T2 would be negative 4. Sharp. And then to find term number 3, so T3 will be T2 multiplied by R. T2 is negative 4 multiplied by 1 over negative 5. Therefore, T3 should be equals to 4 over 5 because the negatives cancel each other. So the third term of the sequence is 4 over 5. We can continue and find more terms. But in this case, I think it's safe or better to find 3 terms because they just wanted us to find a geometric sequence. Sharp. Let's go on and do the third question. Okay guys, let's go on to do our question number 3. So question number 3 goes or reads as follows. The geometric sequence 1, 3 over 2, 9 over 4 has a term equal to 2, 4, 3 over 3, 2, right? So they say, what is the number of this term in the sequence? So this question requires us to calculate what is the value of n, right? So we are given the term, we need to know what number in the sequence this term is. Hence, we have to find the value of n. So we know that this is a geometric sequence, so this equation can be used, right? We are given the value of a. The first term of the sequence is 1. To find our common ratio, we can say it's T2 over T1. This will give us 3 over 2 over 1. Therefore, our common ratio is what? 3 over 2. Sharp. So we can substitute into our equation. So we have 2, 4, 3 over 32. This is equals to what's our a value? 1. Common ratio 3 over 2 and minus 1. So simplify this, it's what? 2, 4, 3 over 32 equals to 3 over 2 and minus 1. Right? So from here we can use logs, right? So the log that can be used here is what we can convert from this rule. Log base a, x equals to a. We can take this to the power form and it can be a to the power of y equals to x. We can move here to the log or we can move from the log to the power form. So we can apply the same here. So in this case we can see that we are in the power form. 3 over 2 represents our base, then y represents the n minus 1 power, and then x represents 243 over 32. So let's take this into log form. So this is what we have. The log of base a, remember we said our base a is the 3 over 2, so we have 3 over 2 multiplied by our x. In this case our x is represented by 243 over 32. So we have 243 over 32. This should be equals to our n minus 1. Sharp. When you punch this into your calculator, it will give you 5 equals to n minus 1. So this, all of this will give you 5. Then from there you can solve for n. So therefore our n value is equals to 6. If you don't want to use a log, you can also notice here that you have what? 243 is the same as 3 over 2 to the power of 5. So you can write this as this, and then you can drop what? The powers, or rather the exponents. So you can still have what? 5 equals to n minus 1. Therefore our n is equals to 6. Okay guys, yo, yazini ngisebenza ngepetrol empty and the load shedding is about to attack South Africa ka Ramaphosa. Anyways, so this is the last question. I don't think we'll be able to do a geometric mean, but if we can also explain it. But so this is the question. The question says determine the second and third terms of the geometric sequence, of which t1 is equals to 2x squared plus y and t4 is equals to 16x squared plus y, close bracket, to the power of 4. So if we check here, we see that term 1, we know that term 1 should be equals to what? A. So it's going to be x, y. This is our A value. So the question wants us to find the second and third term, right? So we know that we are dealing with the geometric sequence. We have to find the common ratio that will multiply on the first term to find the second term, and multiply the second term to give us the third term. So we will use what? Our general term equation, AR n minus 1. And then this is what we'll use, because for A already we have used what? T1. So you have for T4, we know that n should be equals to 4. So T4 is equals to AR4 minus 1. So we know that T4 is equals to 16x squared plus y to the power 4. What's the A? 2x squared plus y r to the 3. So we divide by 2x squared plus y, 2x squared plus y. So this will give us what? 8x squared plus y to the power 3 equals to r cubed. Therefore, if I cube both sides, I would have r equals to 2x squared plus y. So this is our common ratio, right? So we already have our term number 1. Our term number 1 is 2x squared plus y. So to find our term 2, we know that term 2 should be equal to t1 multiplied by r. So our term 1 is 2x squared plus y multiplied by the r value that we calculated. Also it's 2x squared plus y. So therefore t2 is equals to 4x squared plus y squared. So this is term number 2. It's 4x squared plus y squared. To find term number 3, this should be t2 multiplied by the common ratio. So this is 4 multiplied by x squared plus y squared multiplied by the common ratio 2x squared plus y. So therefore t3 should be equals to what? 8x3 plus y cubed. So this is our term number 3. Yo, I can't believe it. Sorry for being fast, but the battery is really finishing. Maybe I'm not even gonna finish this. Squared. I hope you guys followed, you know. So what we did here was to first find what the common ratio of the sequence, and then multiply the first term by the common ratio to find what? The second term. And then after that multiply again to find what? The third term.